Okay, we are recording again.
Okay, great. All right, so I was just gonna maybe explain a few of the constructs that go into this definition, and then I'll show some examples of how the things work, so you'll get an idea.
Hey Isaac, can I ask a
What's going
question
on.
right off the bat?
Oh yeah, absolutely.
So I wondered if you can show us the directory structure just for like a minute or something, because I noticed you have those requires, and I feel like you've shown
Yeah,
us enough stuff that I'm really starting to understand K, but I don't
yeah.
understand like what files you have to have and how they live.
Yeah. In K, right, I'm defining, so in each one of these definitions, so this one's a definition and you kind of know that by the file extension being .k. So in this one, I'm creating the syntax module. So in all of them, I create a syntax module and a semantics module. And basically, syntax module is like, these are all of the syntax constructs that I'm going to use, and then the semantics module is like all of the rewrite rules that are applied to those constructs. But you see, I import the Giro syntax. So this is like all of my rholang syntax I'm importing into this syntax module. So automatically I have to at least import this definition. So it has that syntax module. But then I also have these three that I'm importing because I'm probably using them in the semantics module. So this one's the semantics module. And you know that because by default, if it doesn't have that hyphen syntax, it interprets it as a semantics module. But this one is importing the syntax module from above, and then it's also importing these other three modules that have some functions that I need basically. So like the struct is the structural equivalence and name equivalence definition that I have, and match is like a type inclusion predicate, and this is just like some auxiliary functions basically.
So is this closer to mix-ins or traits?
I'm not familiar with either of those enough to say which one it's more like, unfortunately.
I think it's like a mix-in.
A mix-in? Okay, what is a mix-in?
In Ruby, basically you can, it's like interfaces in Java, but it's much better.
Okay.
Where you can say, this object supports this protocol.
Okay.
And it's just like added in line. And
yeah.
The distributed small talk we used includes for the same purpose.
Yeah, I mean, so I can like the way that I'm using it is just like, okay, I import this auxfun module because I want to use some of the semantics from my auxiliary functions module. So
you're building a library.
Yeah, exactly. I'm trying to remember where exactly I used something like, so like, for example, like I'm using this name equivalence predicate from the struct module, like that sort of thing. I don't remember exactly where I used something from the auxiliary functions, but
okay, so
yeah.
And uppercase letters are required, or
no, not in particular. Well, uppercase letters are required for the formal variables that you're using in a particular rule, but like in the name of this rule, like that didn't matter at all. Like, yeah, not at all.
And if you
go ahead.
And if we import two modules that define the same function with the same name, can you differentiate it, or can you use both, or this like conflict?
Yeah, I think it will complain because it probably won't know. So if I, let's say I have two constructs by the same name, one of them is included in like auxfun, one of them is included in match. I don't think it'll be able to interpret what the abstract syntax tree is supposed to look like, because it calls the module that the syntax is defined in when it produces the AST. So my instinct is that it just won't be able to parse it correctly. It'll probably tell me like, hey, you have this same function that you're calling from one of these two possible modules, and I'm just not sure which one you want.
And you cannot specify the full qualified name. with the module and the function.
I don't know how to. I feel like there should be a way to just say like, hey, I want, you know, this syntax from this struct module or something, and it should work, but I haven't come across how to actually do that. And it also hasn't been so important that I needed it either. So,
Yeah.
So, okay, yeah. So basically the overarching theme here is, so I want to take some rholang term. So basically, like, I'm always thinking about it as like top level par, and then it could have, you know, as many terms as you want that are being, you know, pared together. And then each one of these terms can be any rholang term, but specifically if it's a send, what I want to do is keep track of, you know, what name it's sending on, or at least like what equivalence class that name falls into in terms of name equivalence, and, you know, what the messages are, at least up to like structural equivalence or something like that. And you know, how many of them there are is probably a good idea. So I keep track of how many. So if I have like several sends that are exactly the same name, or name equivalent names and exactly the same message, then I'll just keep track of how many of them there are, because I basically want to take a term and then create several sets out of this term. So the sets that I want to create are ultimately really just these top two sets. So I'll call one the send set and one the receive set. And in the send set, what I want it to do is basically take the rholang term that I put into it and then create a set that basically contains all of the information from all of the sends that are in that term. So if I have, you know, say one send in my particular term that I'm creating this send set from, then I'll want it to basically just tell me that, well, there's only one element, first of all, and that, you know, the send was on this particular name and I'm sending this particular message is basically what I would want. And then out of this receive set, same idea, but what I'm going to do is, given some rholang term, I want it to give me back a set of sets, and each one of those, so the whole set, the global set, is going to pertain to all of the receives that are in this particular term. So all of the receives running in parallel, and then the sets that are inside are going to basically be like batches of listens. So like each receive has one or more listens, you know, either, you know, joined together or whatever. And so what I want to do is keep track of all of the listens in each receive, but I don't care what order they come in. I just care how many occurrences there are of each one of those. And I'm actually not even sure I'm keeping track of that yet. It got very complicated very quickly. I think, actually, never mind, I take that back. I am keeping track of that. And I can tell that I'm keeping track of that because I have something like this. So here I'm looking at this category called K item. And a K item is basically anything that I can make into like a set element or a list element or something along those lines, like for built-in sets or lists in K. And so this one here,
can I ask another basic question real quick?
Oh yeah, absolutely, yeah.
On lines, like for example, 26 and 31, or for a different example, 21 and 18 and 12.
Yeah.
How can you define? It looks like you're defining the same thing multiple times. Like set, it looks like set got defined as syntax 3 times, or bool got twice.
So I'm defining, so like here I have like set, and then I define all of these different constructs in set, right? That's kind of what you're talking about. Or just the fact that this one took a set, or maybe this is
no, it's not the recursive aspect that's confusing me. So like lines 12 through 15, it's like you defined a couple different constructs that together constitute set, right?
Yeah.
But then on 18, are you like are you like just adding a 5th one, or are you what does that do?
Yeah. So writing this here, well, so I guess one advantage is, so basically, let me even take a step back. Basically, all I'm saying is, anytime you see this send set of a process, just know to interpret that as type set. But so I'm adding this particular construct to the syntactic category of set. So anytime it sees any of these things that I've deemed as sets, it will know that it's supposed to be a set. And then basically, since I'm declaring it as a function as well, it's going to evaluate until it gets to a result. And my results, which I didn't actually put here, and maybe that's why I'm having some issues, I can just tell it like my results are always going to be sets, basically.
Oh, okay.
And so
Okay,
then,
so when you do like syntax set : equals something, it's not like overwriting or eliminating the previous ones. It's just adding another one.
yeah, exactly. So just to make the point even more clear, right? So you can give precedence to the syntax. So I can say like, for whatever reason, if I really want the send set syntax to be higher precedence than the rec set syntax, then I can make it such if I include all of them in this same thing. However, that doesn't really tell me how the precedence of any of these four compare with the precedence of this flattened thing here. But I mean, the way that I currently have it written is equivalent to writing it like this as well. So those are all the same. Right. So
okay, okay. That totally answers that.
Yeah, I could just mash them all into the same one. But for me, I kind of like to separate them according to like what I ultimately want to use them for.
Yeah, totally. That makes sense. Okay.
Yeah.
Thanks.
Yeah. So for me, like these are very different than these, because these are kind of like my set constructors, and these are like binary operations with sets. So this union is not like usual union. It keeps track of like how many occurrences of the element there are. So it's kind of like a multi-set union. Yeah, so those are the constructs basically. So like I have some way to build these sets that contain information about sends from the processes directly, and then also some way to construct basically nested sets from received. So I'll show you an example of one of these things.
And this set is not like a K-framework set built in, right?
Yeah, it is. So I'll get back things like this.
Okay.
Like here's one set item, it looks like this. Here's another set item, it looks like this. But that's not the one I'm actually looking at.
But also a bag with in what you call set.
Yeah, well, so a bag is a little bit different just because I can have the same element many times, but since I'm using the occurrences, they're essentially the same thing, right? Because like I'll want this to interpret. So for example, right? Let's just look at this process that I have here. So it's like I have some send on X. I have some receive. This shouldn't affect my send set whatsoever, because ultimately that's what I'm building here is the send set from this thing. Some other receive, whatever, it's joined, doesn't matter, shouldn't contribute to the send at all. And something in a list, so that also shouldn't contribute to the send set at all. So there should only be one thing in the send set. It should have an occurrence of 1, and it should be a send on channel X with the messages 1 and 2, and that's basically what it's going to give me out of this, is that, well, here's the channel that the send happened on. There was only one of them, and the messages were 1, 2.
So you have like a constructor send set.
Yeah.
And you're accepting any proc.
Yeah.
But you are interested only in sends.
Only in sends. Yeah, exactly. So yeah, just real quick, if you want to see more of the details, I can show you more of the details. Well, I mean, really, send set is very easy, right? Like if it sees a send, like give me the element that corresponds to it. And if it sees a par, well, then basically let's create the send set of the first thing and the send set of the second thing, and then take this union of them where, like I said, this union is basically something that respects number of occurrences and counts up if you have the same, if you have the same elements, modulo equivalences, and, counts occurrences of the element, like total occurrences.
I see. So syntactically, you are accepting any process, but you have like a semantic rules that only apply to sends and parse.
Yeah,
right?
Yeah, exactly.
And
right.
for all other, you have empty set.
Mm-hmm. Yeah, exactly. Yeah. So, I mean, this send set will take in anything, right? But if it's not a par that it has to like tease apart at the top level, then basically it only cares to see a send. And if it doesn't see a send, then it just gives you back an empty set.
Can you define in syntactic rule? Can you say? Can you be more granular and say I'm accepting sends, and this will be like a constructor for set, but can you use empty set here in syntactic rule?
Can I use the empty set? Well, so like I could just say I'm only accepting sends here, or I'm only accepting pars or something along those lines, but maybe I wouldn't even want that.
Yeah.
I don't know if that's what you're asking, though.
Yeah. Can you say just a send?
Yeah, definitely. I can. I can definitely just say a send here, and I didn't want to, only because I wanted to be able to parse any rholang term, right? So I wanted to be able to see something like this, see that there may be, this is not the best example. I think in this other example, I might have more sends.
You might want a send set that only has sends in it, and you might want a send set that only has receives in it.
Yeah, right. Yeah, so I mean, if I were to feed this send set like, tons of processes in parallel and none of them are sends, it should just return me an empty set. Yeah, because it'll just, split over each element of the par and then analyze each one of them, and if none of them are sends, it'll just return the empty set.
Okay, so send set wouldn't include the receives.
I mean, well, so it does, but if I were to just like, well, first of all, in this one, right, it's like I have these 3 sends, they're all exactly the same channel, same message, everything. And what this will do is when I ask it for the send set of this thing, it'll basically just collect all of them as one element, but it occurred 3 times, right? So it'll tell me that there's actually 3 occurrences of this particular send. But if I were to go ahead and just delete this from here, well, there's clearly no top level sends anymore, right? So it'll just give me back an empty set if I were to run that.
Okay, is there a corresponding receive set?
Yeah. Yeah, so with this one, and now I feel like it's taking even twice as long as it used to take in the past. I'm pretty sure I'm at over a minute or 2 for compilation time, but I'm not even compiling. I'm just trying to run this thing.
I think Zoom.
There we go. And Zoom definitely messes things up a lot, but that's okay. But yeah, so I got back an empty set from taking that stuff out, but that's only because I'm keeping track of just the sends that are occurring in that process, right? So no sends, so I get an empty set. So yeah, I do have another constructor for receive sets. Let me get rid of these. Yeah, so the receive set, like I said, is it's nested sets, and so the reason that I chose nested sets for this one is because I wanted it to see some receive as basically containing a set of all the different listens or bindings or whatever in that particular receive. So basically, what I'm thinking of is every time, so when I'm looking to construct the receive set from this process, I'll do the same kind of thing, like analyze for pars and like, okay, this is a send. So of course it's not going to appear in my receive set whatsoever. So I can kind of ignore this first term. But the second term is a receive. So then the question is, how do I want to handle that? And so the way that I chose to handle it was to create a set within that outer set. So it's like a nested set that contains, well, it has 3 binds, so it'll have 3 elements. None of them are repeating or anything, so I can just go ahead and I have 1 occurrence of each of them. And I think I actually only need 1 occurrence for each of these bindings, because you can't literally have the same one, because you must have different listening variables. You want your listening variables to be unique in your in each receive. But either way, so there are three listens here. So I have listen on X for A, and that's this element right here. I have a listen on Y for BC, that's this element here, and then I have a listen on Z for, I put the slash before a process variable, so this is just like listening for some quoted process variable, but I have that corresponding element right here.
We do actually reasonably often have 2 listens on the same channel.
Yeah. Two listens on the same channel is okay, but you won't be listening for the same variable as well.
Okay, never mind.
So like like that would be totally fine. But if I were to then further do that, this is no longer okay, right? Because then the whole question is like, okay, I could get 2 different values on X. But which one is the one that actually gets substituted in for A? It just seems really weird. You get errors in our node, at least, for something.
Isaac, I want to just inception an idea into your head here that I was struggling with yesterday.
Oh, okay.
I was trying to express something that, wait, no, put it back to how it was.
Sure. Oh, okay. I didn't know if you were talking about
I was trying to express, I want to receive 2 messages. Or actually, it could be from X and Y. The channels don't have to be the same in this case.
Okay.
I want to receive the same message from 2 different channels atomically, like with a join. So I want to receive some message from channel X and the exact same message from channel Y. Don't take either one until they're both there, but it has to be the same message.
This is the one you were asking about this with a variable reference, right?
Yeah, I had done something like X for X from some chan and equals X from the other channel.
I have a pretty good feeling that you can do that with input guards.
Oh.
Yeah, like just, so you might not be able to say literally identical to, but you can say structurally equivalent to, and you could definitely do that with,
that's structurally equivalent is exactly what I meant.
Yeah. You could do that with input guards for sure.
Yeah, that's right. So it would be like for X from A semicolon Y from B if X equals Y.
Yeah, exactly. So exactly like this. Y from...
Although, Josh, your example, for me, it seems logical, right? I mean, these 2 bindings are not in sequence, but...
Yeah.
I guess mine has to be like this, but either way, it doesn't really matter so much. Yeah. So
you were saying like you thought it also seemed like a reasonable way to say it when you just did like X and then equals X.
Yeah. I mean, it's the same, right? You will have definitely X and Y available.
Yeah. Well, as long as there's any way to say it is mostly what I care about.
My guess is that this is the way to do it, or a way to do it. I don't know if there are others. I wasn't sure how the variable reference stuff was supposed to work, because my understanding was when you did that variable reference, you were looking for to change the name of a variable or something. I don't actually remember. I've never used it for anything.
Are you talking about equal X?
Yeah, yeah.
Oh yeah, it means that it means you're not trying to bind, or like in the way you've written it down here. Yeah, X would be fine. Like if that said for equals X from A, it would mean I'm not trying to bind the name X. I'm trying to pattern match the thing that I get from channel A, and I want to match it against something that I already have in a variable called X.
Oh, right, right. Okay. Yeah, it's like if you have some variable X that has a value, you just want that value on the variable X, right?
Exactly.
Yeah, okay, okay. Cool. I think this will work. I'm not really sure though.
Yeah, cool.
So our node doesn't have this input guard stuff though, right?
Yeah, or I don't think so.
Okay. Yeah, I haven't really checked. I also have like
input guards
versions older than where they're actually at right now, but
yeah.
It doesn't have what?
Input guard. So something like this, you know, like could I run this in our node? I don't know. It'll take 15 minutes for my R node to start up. Otherwise, I would do it. I'll comment that out and try it later, maybe. Yeah. All right. Yeah. Go ahead.
Yeah, I think that someone said this is not implemented. I never tried.
Yeah.
It would be an and, right? So
where?
//
Sorry, say that again.
The if would be an and.
You do this?
No, //
Oh, this. Like that.
Right.
Oh.
I don't think that's gonna work.
I don't think that's proper syntax though.
Right.
I mean, it's a pattern. It's meaningful. So
well, yeah, you have to use that operator in the context in a pattern though, and that's not in a pattern. Like the patterns in what Isaac has are X and Y.
Yeah.
Oh, I see.
Yeah.
So we're saying A and that.
Yeah.
We're not saying we can put parentheses around the join.
Well, so for me, this is, you know, this parses as a list of binds, but I don't have so and this operates on, you know, processes or patterns. But binds are neither processes nor patterns.
Right. So the correct way would really be to say if.
Well, yeah, that's how I have input guards, you know, interpreted. So this is my syntax for input guards. I think that's how it's supposed to be. I'm not sure. It could be changed very easily, though.
Right, but how is that superior to putting an if in where you have the nil? Oh, because it actually does the read. No?
Yeah, you don't consume messages unless that condition is also satisfied.
Yeah, that's the really cool thing. You could definitely, in the same way that we kind of hack our way around peak, you could hack it by like putting the if inside of the continuation, and if the if happens to be false, then put the stuff back on the channels.
Oh, right.
But it's not quite the same semantics.
That makes sense.
I think it would be more correct to put parentheses around the two joins and use the and operator for the if.
Oh, yeah, that's interesting.
But this and is not operating on booleans.
It's a pattern. That's all. It's a pattern operator.
Yeah.
That's what
but this equals y is a boolean.
Yeah. Well, I mean, I can show you how I'm implementing this stuff, right? So I got patterns added in here fairly recently. So at least the way that I'm treating it, right, is like with negation, you can negate a single process. With and, you can and two processes together. And I was thinking that this is doesn't really make a whole lot of sense to be able to do something like this, just because a process is only ever going to match one thing And so why would I ever need it to have two different processes? But
I think
that's
it's
still
not in terms of like set complement. So in as much as the pattern describes like a set of things that match it, not just basically like saying the complement of that.
Oh, it's exactly the complement. Yeah. And it even works like these three operators all work together like intersection, union, complement. There's De Morgan's laws between them. I was really happy because my type inclusion predicate is actually recognizing De Morgan's laws now. So that's pretty cool.
Oh, wow. Cool.
Yeah.
So by type inclusion, you're saying like, does this thing match this pattern, this process?
Yeah, right. Yeah, I have this entire module called match, and basically it'll work on the level of two processes, two names, several processes, several names, or patterns, name patterns, process patterns, whatever you want, basically.
Yeah.
Yeah, but the way that we're getting a little bit off topic, but that's okay because this stuff is pretty cool, and I'm really happy about all of this working out. Well, right now I have like 80 parsing errors or something, which is okay because the other day I had 5,200 parsing errors, and I was just like, whatever, man, 5,200, who cares? I added like 3 constructs, and immediately it was good and compiled again. So
more errors than characters.
Yeah. Oh yeah. So here's how it works exactly like complement. So like for this first rule, for example, so what I'm asking here is I'm asking if the first thing matches the second thing, which is basically just set inclusion, right? Like the set that corresponds to this pattern on the left, is it included in the set that corresponds to the pattern on the right? And so I'm asking for not A included in B, but that's the same as not the set, that corresponds to A being included in not B, right? So this is like literally how it works like a complement. So it works like a complement in the sense that, it works like set inclusion in the sense that it's like contravariant in the first element and it's covariant in the second. And by that, what I mean is like, so something like this, when I take negation off of the first element, it goes to the second element. Basically, if we look at this rule here, right, it's like I have an and on the included inside, and it goes to an or statement, because when I'm saying something like the set corresponding to A intersected with the set corresponding to B being in this set C, well, the only way for that to be true is that one of those guys has to be included here, and then this intersection will work out correctly.
Okay, all right, hold on a second. I want to dive in on this one. So it says A is a process, and B is a process.
Can
you use that operator between two processes?
Not particularly, but you could.
Well, so what does it mean when you do?
Well, yeah, right. So it's not going to mean a whole lot, really, because in the vast majority of cases, this is just going to correspond to an empty set, right? Because like this can only be one element, and this can only be one element. Yeah. So if they're not the same or like structurally equivalent or something, then
so that happens to be one of the maybe less interesting ones to dive in on.
Yeah, right. So maybe this, okay, let's just go for all patterns, right? Like maybe that's the one.
I think my point is that that if they're let's say they're both twos.
Mm-hmm.
You've matched the pattern and guarded the
thinking about input guards.
You've got an input guard.
Yeah.
So if one's X and one's Y and they're twos. I don't know.
Yeah.
But in any case, it was only an observation really that
Mhm.
the and operator um, in a pattern in rholang is a guard.
It's
on
very interesting because definitely I can write, and like I don't have a way to interpret this yet, but definitely I can write something like this in the sense that I can receive patterns. Well, okay, not exactly like this. I mean, it would have to be a little bit different. I'd have to like quote this entire thing or something. But either way, I can take some patterns. So you have like process patterns and name patterns, just like processes and names. So this thing would constitute a process pattern, and I can receive any name pattern. So I'm wondering if I could do something like this, like basically somehow designate, well, okay, and the syntax is even still wrong, but either way, somehow designate that, well, but this shouldn't even work either. I'm just wondering if there's a way to do this where I somehow designate that this is like the thing that I'm listening for from channel A, and I also want it to match this this pattern here, but I'm not sure how to enforce that.
Yeah, I think.
Oh, yeah.
The version.
Well, yeah. I would think you wanted to say equals X right there, which is exactly what I had tried to say earlier.
Uh-huh. Yeah, I mean, yeah, if we could even just say, something like that would be great. But then I guess the question is like, how do you know which one is the one that you're listening for? I mean, I guess there's just some rules for it or whatever, but.
Yeah, well, you could change that to an equals X, which says I'm not
Right.
trying to bind anything. I'm trying to use something.
Yeah.
Oh, yeah, that's not even quite what I meant. Yeah, well, that's exactly
something along those lines. Yeah.
That's actually not quite what I meant, though.
Oh, okay.
Like, what if Control Z just a couple times? Yeah, a couple more. Yeah, there we go. Okay. So you're doing that like Y, and then at some point it was and.
Yeah.
Y, like.
Yeah, I think maybe
Oh,
two more back. There we go.
Yeah. Oh, yeah, exactly. So the question was like, how do you know which one you're trying to bind? You said, right?
Yeah, right. Yeah, but I guess it's pretty obvious when this one is not a variable and this one is, but I don't know.
Oh, yeah.
Yeah, I'm not sure. I think there is definitely a way to make this work. But from my perspective, at least, it's like, well, this already works.
Yeah,
Why
totally.
do something else as well? Like that already works.
Yeah, that's a great way to do it.
Yeah.
So okay, so we were looking at that type inclusion stuff, right?
Right. Yeah. We could go back to that real quick. Match here. Yeah. So I think we were thinking about
one of those lines. Yeah, that one. So the question that you're asking on the left side of the arrow, you're asking, does C match B, and also does C match A? Right? Okay, and then so you rewrote it to how?
So this is like basically so this is like we have two sets. We're taking the intersection of it, and then we're asking if that's included in some third set C.
What that arrow, does that mean less than or equal?
Yeah, and I mean, and really the way that they do it in K is like that, right? Then it's a set inclusion.
Okay, I was reading it backward. You're asking, is the thing on the left of the semicolon included in the thing on the right?
Yeah, exactly. Yep.
Makes perfect sense.
Yeah, so yeah, when it comes to the patterns, at least, right? Match of A colon or semicolon B is, well, okay, this just means, right, I'll put that or something. This just, well, I'll put that makes sense. This is just like is A, yeah, less than or equal to B, or included in, or, you know, whatever.
Yeah. Okay. So then on that one we were starting to look at on line 357.
357, yeah.
So we want to make sure that the union of A and B is included in C, right?
Well, the intersection.
That's the intersection?
Yeah, yeah.
Oh.
Yeah.
Yeah, okay, I see.
So, well, so what I was thinking was basically like to have the intersection of A and B included in C definitely doesn't mean that each of these need to be included in C. But it would certainly be enough if one of them was included in C, then we would definitely have what we wanted. And so that was kind of the motivation to make the reduction rule the way that I did.
Mm-hmm. So,
Right.
okay, so that rewrite rule, so definitely if A is included in B or A is included in C, then the thing on the left is also true.
That's
But
right.
it's there, I think, like you were saying, there are also other cases, right?
Yeah. Oh, yeah, definitely. Like, it doesn't need
like
to
those,
be
we
the
don't know how to
case.
detect those.
Yeah. Right. Yeah.
Yeah.
And so, like, there's probably more work to be done here.
Yeah. Okay.
But to do. Yeah, certainly more work to be done here.
Cool.
However, with something like a union, though, if I'm asking about the union of two sets being included in a third set, yeah, it absolutely must be the case that both of them are included in this thing. So
Right.
these
So
ones,
those
ones are definitely good.
Yeah.
Yeah, there may be some other weird like portions of complements that I should be checking in this case to make it even more tight, I guess.
Nice.
Yeah, because this will say false for things that maybe shouldn't actually be false. Yeah. Yeah, cool. All right, I'm gonna.
All right, I get how that works now. That's cool.
That here for later. Okay, sweet. Yeah, so this is the type inclusion predicate, right? So I'm even extending it to patterns now, which is really nice. But so basically, the thing that I was saying is it's kind of contravariant in the first argument and covariant in the second argument, in the sense that it's basically doing the opposite that you would think it would do in the first argument. Like here, like my ands are going to ors, my ors are going to ands, and then up here, when the patterns are in the right argument, it's doing exactly what you would expect. So like if I'm doing like a pattern and not pattern, well, then that just comes out as not like matching those two patterns without the complements on them at all. And something like the and predicate, you know, here with all patterns, right? It's like, so I'm asking if A is included in the intersection of these two. Well, it would have to be the case that A is included in the first one and A is included in the second one, basically.
Yeah.
So how do you define covariant and contravariant? Can you specify somehow this, or?
Yeah, so covariant and contravariant are in terms of like type inclusion. So like if I were, the way that it always works is like if, so to say that the left argument is contravariant is to say that if I were to take some larger, type in the left thing, how am I trying to say this? If I were trying to, So I guess I don't have a good way to explain this covariance and contravariance, but basically it's along the lines of like taking more. I can't. I don't know why I can't think right now.
Is this like a direction in which you can extract value or input? You know, I'm not sure that.
Yeah. So, okay, maybe this is a good way to describe it. So like if I were looking at something like, you know, match A, B, right? And then, so I'm looking at something like this and I don't know how I want to explain it. So I'm looking at something like this, and you know, so like A is a fixed thing, right? And then I'm just like B is kind of like a parameter, and I'm just saying like, okay, it's either true or false for like whatever value of B I put in here. And if I were to replace A with something from like a super type of this particular value of A, I would actually get less things to give me a true value. Basically, this is the worst explanation of contravariant or covariant ever. But basically, what I'm saying is like if I were to look at some larger structure here on the left side, I'll actually get less true values. But if I were to look at some smaller structure on the left side, I'll get more true values, I guess is maybe the way to say it. As opposed to on the right side, if I put something that's like smaller in terms of like the type or something like that, I'll actually get more true values for arguments on the left. Whereas if I were to put, if I put something smaller, I'll get less, and if I were to put something larger, I would get more true values.
I see.
So when you're doing subtyping,
yeah,
it's variant if you're doing a kind of typing, an is kind of typing. Like you're subtyping animal to cat. And a contravariant would be if you're you're casting an animal to a string. Okay, you're specifying an animal as a string, as a contratype to animal as a cat, as the animal to a cat would be variant.
Yeah.
Is that clear?
I think so. I don't know if variance is clear in general. I feel like it's one of those things that I'll understand for 15 minutes and then I'll forget it, and I can't possibly hold on to that understanding for some reason.
So in C#, you can define generic parameter to be covariant and contravariant.
Yeah,
so
yeah.
You really, and this is my question for you. Do you have some kind of operator to say this parameter is contravariant or covariant? You know, because in C# you need this kind of notation, so you can prevent what Jim was saying. If you cast, you can end up in situation that it's not type safe anymore, because you're casting to a more general type, and then you're adding elements which are different types.
I think that the simple way to understand it is that a cat understands the language of animal, whereas a string doesn't understand the language of an animal.
Right. Yeah, that totally makes sense. Yeah, there's also a way to define the variance in Scala, but I haven't seen it in K, like anything explicitly defining variance of operators or anything like that.
I see.
Yeah.
Okay. Okay.
Yeah. So for me, I'm trying to enforce that variance just through how I'm defining, the predicate values on certain constructs, basically.
Cool.
Okay, maybe we'll talk about the actual thing that we were trying to talk
I had
about.
no clue, so I looked it up in Wikipedia.
Oh, cool. All right, so let's see. So, we talked about this receive, right? We had 3 different listens from that receive, and that's what this set. That's the information contained in this set with 3 elements. We also had. Let's see. This thing keeps getting in the way. So there's 2 more receives here. So one of them is listening specifically for the messages. What happened here? Oh, okay. Sorry, never mind. There's one other receive, but it has 2 listens as well. And so the 2 listens that it has, well, they're on technically, syntactically different channels, but you can probably see that they're alpha equivalent fairly easily. So we're listening on alpha equivalent channels. So basically the whole point of running this example was I wanted to see that this receive here actually only corresponded to 1 set element with an occurrence of 2. And so that's exactly what we're seeing here with this set. So this set just has 1 element. Of course, here's the only element. And it's telling me that the channel that the message was sent on is just this new X and star X. And I think it picked that one just because it was the second one. I am coming up with a way to define an ordering for all of the elements in a particular equivalence class, either process or name equivalence class. And what I'll ultimately do is make it return the lowest order element. So there will be a canonical representative of each equivalence class. So ultimately, that's what I'll have it display instead of just picking the second one and then displaying that. But either way, the whole point of that was to see that, well, we actually only got a set with 1 element from this receive. That's what we wanted to see. But specifically, that 1 element should be repeated twice, and it is, and that's why I have this 2 for the occurrence here. Right, so then the receive set for this entire process is going to be, it's like a global set, and then each one of the elements in the global set is a set itself, and that set expresses something about the bindings in each one of those receives. So like this was a set that contained a set with 1 element. That 1 element, had an occurrence of 2. Here's the channel. Here's the listening variables or whatever, and a set that contained 3 elements, and those 3 elements, corresponded to the 3 listens in this particular receive.
Well, this has been awesome this morning. I'm going to have to go to another meeting now.
Okay.
But, I'll make Joshi or anybody who wants to be the host.
Cool.
And if I can find the participants here. You can start another recording. I wish
Sweet.
I could stick around thinking about how how this relates to space-time and consensus to kind of bring the circle back around. I mean, it may be this is just blowing my mind into unrelated directions, but I wish I could stick around and talk about it. Later, guys.
Yeah, absolutely. See you, Jim.